In the last video on displacement, we talked about the fact that displacement is a vector quantity, which means it has a direction. It can be labeled as positive or negative, and the only difference between a positive displacement and negative displacement is the direction. So next we're going to define something called velocity. Before we do velocity, though, let's talk about speed, and I want to review what speed is by looking at a track meet. In the displacement video, we talked about the track meet, and I asked you which event would the displacement not be 0, and the answer would be the 100 and 200 meter dashes, because you don't start and stop at the same point. So now what I want to look at is a 600 meter dash from the 2008 girls Big Ten Championship. And it's a 600 meter dash. So we're going to say the displacement of the girls is 0. The distance they travel is 600. So let's watch and then we'll talk about it.
The 600-meter underway. Heather Dorner in Minnesota finished second in this event a year ago. She was in lane 4.
And Dornan is probably going to be your favorite. She actually won the NCAA championships in 2006 in the 800, but she only won 1 Big Ten championships in the 2 years.
3 laps in this event, 600 meters, 3 times around the 200-meter track here at the field house.
What a bold move by Fawn. She's looking very confident, and the Penn State runner is just running amazing today. She did win her heat in the 400, but ended up taking 4th overall.
That's Fawn Dorr moving into the lead, a sophomore from Penn State. Dornerton running second.
Dornan last year scored 23 points for the Golden Gophers in their Big Ten championship, so they're really relying on getting a lot of points from her this weekend, and she's just coming by Fawn Dorr now in the home stretch, heading into the bell lap. Oh, went down.
Dornerton falling down, gets up quickly, but that's going to cost her. Lucky she wasn't injured.
Her teammate just went to the front, though, so they may be able to recover from that. And Dornan is flying down the backstretch.
She is catching up.
She is going to catch Fawn Dorr, and she may catch the leaders.
Wow.
Wow. She's got Fawn.
This is a gutsy effort by Dornerton. Can she pull it off? She's moved into 3rd. Dornerton coming down the stretch from the outside. Dornerton coming on strong. Dornerton all the way. Dornerton. She did it. Wow. Unbelievable.
That is amazing. To fall in a 600, I mean, this is basically a sprint. I mean, this is an extended 400, basically. To fall with 200 meters to go and get up and win, that is unbelievable.
Unbelievable.
That's one of the most exciting I've seen. Here's the fall.
Oh, she tripped on Fawn's shoe.
It looked like Fawn just clipped her heel, and she went down just before the bell lap.
Fawn Dorr had to high hurdler to avoid a collision.
And she is powering down this home stretch, just doing everything she can to win this heat.
So I love that clip from YouTube, but we can get a lot of physics from this. So let's take a look at it. The runner, we know, ran 600 meters. And that is her distance. Okay? If we take her distance and divide it by the time it took, we will get her speed. And speed is what is known as a scalar quantity. A scalar quantity only has magnitude. It doesn't have direction. So speed only involves total distance. So the time of her race was 93 seconds. So if we wanted her speed, we would do 600 meters divided by 93 seconds, and we would get a speed of So in this case, the speed would be 6.45 meters per second. That would be her speed. But in physics, we deal with vector quantities. So if you remember, the vector quantity is one that involves direction and time, direction and magnitude. And so I need to introduce a new word. And the new word is velocity. So velocity is just direction added to the speed. And so the velocity is defined as the displacement of a person or an object divided by total time. Or actually divided by change in time. And you'll see why I change that, a change in time. And as an equation, it can be written as delta x, change in position or displacement, over change in time is equal to xf minus xi over tf minus ti. So this is our next equation. So one thing to note when using this equation is that this velocity is an average. Okay, so let's do a problem. All right, so let's take a look at this problem. It says, during a race on level ground, Andrea runs with an average velocity of 6.02 meters per second to the east. So I put the displacement in red. So we are dealing with the velocity, not the speed. What is Andrea's displacement after 137 seconds? So since this is our first problem, I'm going to introduce a problem-solving method to you guys, and I'd like you to employ this. You can try it. Once you get the knack of solving physics problems, if you want to maybe branch off and try your own thing, you can. But what I would like you to do is set up a chart with your known values and the value you're trying to find. And then we can have an equation that will help us find the answer. So the things we know the velocity, 6.02 meters per second. So v is 6.02 meters per second. We also know the time is 137 seconds. And we were trying to find her displacement, or delta x. So is there an equation that involves v, t, and delta x? And we see that there is an equation. V, velocity, equals delta x over delta t, or displacement over time. So now I know that the equation is v equals delta x divided by delta t. However, I want this equation I want to solve for x. So I need to rearrange this equation. So since I want x by itself, I need to multiply both sides by delta t. If I multiply this side by delta t, the delta t will go away. And then this side will have the delta t. So it's going to look like this. I'm going to multiply by delta t. Bye-bye. There it goes. And I end up with an equation that is delta x equals v times delta t. And now I plug my values in for v and t. So we'll come over here. We'll come over here, and we'll get the displacement is equal to 6.02 meters per second times the time, which is 137 seconds, and that gives us a final answer of 824.74 meters as the final displacement. Okay, so in the next video we'll look at how to use this knowledge of what velocity is and use it in terms of a graph. All right, physics is fun.